Hi, I'm Bob Swintek. Last month, the U.S. Food and Drug Administration revoked the GRAS status of partially hydrogenated oils and their artificial trans fats, and has given food manufacturers 3 years to eliminate the use of PHOs in their products. Several ingredient suppliers at the IFT15 Food Expo are offering trans fat-free alternatives to PHOs. Let's hear how two organizations are helping product developers meet the challenge of removing partially hydrogenated oils while maintaining the functional requirements of taste, texture, and shelf life.
Richard Galloway, I'm the staff consultant to Qualisoy. The biggest challenge to meeting the partial hydrogenation ban is really functionality. Partially hydrogenated oils have a really broad spectrum of functionality built into them that's very difficult to emulate with other processing methods. Most PHOs have been removed. Certainly the easy to replace applications have all been replaced. We've been working on this as an industry now for 10 years. So we've removed something like 75 to 80% of trans fats from the diet. The applications that remain, things like pizza dough, donut frying, shortening, similar categories to that. We've just had difficulty producing products that will give us the foods that consumers expect and accept. There are two things to consider. I would say three things to consider. I think the most important is the functionality. Can you find a replacement for the PHO that you're using today that produces a food product that your consumer has been buying? And if it changes that product, then is that really the way you want to go? Number two is nutrition. Do you want to swap trans fats for high saturated fat? Is that an issue? So that's number two. And number three is cost. Certainly, like anything in life, probably the best solution costs a little bit more. So what is your balance between risking losing sales, changing your product, maybe changing it significantly, and retaining sales or maybe even growing sales by producing a high quality product with a reasonably good nutrition profile? Well, the soybean industry really has two general solutions for the partially hydrogenated oil being used today. One of those is a blend of fully hydrogenated oil and liquid oils. You can blend that with liquid oil, mix it up, and you can replace some applications. Clearly, taking two types of oil, a liquid oil and a solid oil, and shaking them up, mixing them up, really can't give you all of the applications that partial hydrogenation can do. So the other process is known as interesterification. In that process, we take fully hydrogenated oil, again, not adding any trans fats. We add an enzyme or a chemical catalyst, and we basically produce the same spectrum of melt curves and melt points that we were able to do with partially hydrogenated oil. Now, I would add to that high oleic soy. When you blend fully hydrogenated oil or interesterified oil with a commodity oil, you don't achieve the oxidative stability you had with the partially hydrogenated oil. If you blend the fully hydrogenated oil and the interesterified oil with high oleic soybean oil, then you're able to emulate that same oxidative stability as well as the physical characteristics. At our booth at the show, we're going to be featuring mini cupcakes. The cake itself is made with high oleic soybean oil, and the frosting is an interesterified soybean oil. So really delicious mini cupcakes.
My name is Gerald McNeil, and I'm the Vice President of Research and Development for IOI Loders Croclan, North America. There are two categories, broad categories that we need to address. One is the liquid oils, and the other one is semi-solid fats. And semi-solid fats are definitely going to be the most difficult category to overcome, because over the last 50 years or so, butter, beef tallow and lard, that's all we had for baking and snack foods, and they were all replaced by partially hydrogenated oils. The problem with that is that partially hydrogenated oil is very, very versatile. It's a chemical process, and the conditions can be altered to get all kinds of different textures for a wide range of different products, and also to accelerate production, with faster crystallization. So there are many, many barriers to overcome, and baked goods and snack foods, they're really the problem. They all require a semi-solid fat. On the other hand, we have liquid oils. It's a little bit easier to deal with. The issue there is deep fat frying, I think, or frying in general, because some of the non-hydrogenated oils like soybean oil and corn oil, they're going to degrade very quickly because you can't get rid of the very highly polyunsaturated fatty acids. So the good news there is that we have canola oil, which is high in oleic acid. It's stable, and that's been used for several years now since the mandatory label came in 2006, I should say. Back in 2003, when the FDA announced the mandatory label, we decided that the most versatile solution is palm oil, because it's a natural product. It's naturally semi-solid. It's like butter in its texture, but as well as that, through a physical process called fractionation, we can separate out all of the different triglyceride components that are in the palm oil, and separate them out using fractionation. That's a physical process. So we melt the oil, cool it down slowly, and big crystals form, high melting crystals. We filter those off, and then we have a liquid oil and a waxy solid oil, fat. So now we have three products. So what we can do with the fractions, we take those fractions and do that again, under different conditions. So we have about a dozen different semi-solid fats with different physical properties. And so instead of just having one natural product. Now, and that's only half the story, because we can blend those fractions back together in different proportions, add in liquid vegetable oils like soybean oil, sunflower oil. So what I'm trying to say here is that we can make an almost unlimited number of different kinds of very functional products without using any chemical processing.